So the rest of this unit is really just going to be volume of three-dimensional figures. So we're going to start with the volume of prisms and cylinders because they're essentially really the same. If you remember from a couple years ago, I think you probably did this in middle school, maybe. Volume is how much the amount of space inside of a figure, how much you could fit inside of a figure. And in order to really do the volume of a prism or a cylinder, let's just quickly go over the volume of some two-dimensional figures because that's really going to help us here. So the area of a circle is pi r squared. The area of a square is side squared. The area of a rectangle is length times width. The area of a triangle is 1/2 base times height. So this would be the base, and the one that makes the right angle here, that's our height. And our area of a trapezoid is base 1 plus base 2. Base 1 plus base 2 divided by 2 times the height. So we could say this is base 1, this is base 2, and it's the altitude height. So I just want to make that clear. That's the altitude height, not the slant height. So that's our area of our two-dimensional figures. Now volume is kind of like you just keep stacking up these areas on top of one another, and then eventually you'll get a prism. Now we have a very general formula for all prisms and cylinders, and its volume is capital B, which stands for area of the base, and then times the height. So volume equals capital B H. This here stands for area of the base. So now a cylinder, the base is a circle. So the base of a cylinder is a circle, so the volume should be area of the base times the height. Since it's a circle, it's pi r squared times this height here. And that's going to be for all of these, really. So it's going to be very simple for volume. You just need to know it's area of the base times the height. Again, a square prism is area of the base times the height. Since this is a square, it's side squared times h. A rectangular prism, again, volume is area of the base times the height. The base is a rectangle, so the rectangle area is length times width, and then we just times it by the height going up. Triangular prism, again, volume is area of the base times the height. So volume equals 1/2 base times height, base height, and now we can call it like it's a second height. It's the height going this way. In this case, it was labeled as L, so I'll just call it L. But it's this area, so it's whatever this area is, and then times however much we need to go up by or across by. And trapezoid, again, area of the base times the height. Trapezoid is 1/2. Actually, I'll do it the way that I did here. Base 1 plus base 2 over 2 times the height times this height. And then, I don't know, like the length going across or the height going across, so times the length. Essentially, really what I want you, the big understanding here is it's going to be this area times this height going across. And that's going to work for all prisms, all cylinders. It could work for right prisms and right cylinders or ones that are not right. And I'll explain what that means in a moment. But all of these have been right cylinders or prisms because there's like this right angle here. So if I could draw it in green here, right angle, everything's basically forming a right angle. You know, these are all going to be right angles. So we're just kind of really looking at right prisms, right cylinders. We'll explore in a moment what something that's not a right cylinder or prism looks like. Okay? Again, volume is a measure of the amount of space inside of a figure. Any cylinder or prism is area of the base times the height. So for any of these shapes, anything at all, it's this area, this area, this area times the height of your prism, so times the height in green. So we'll look at a couple of examples. We'll maybe skip around a bit. So our first one here is a packing carton is in the shape of a triangular prism, shown in the diagram below. What is the volume? I'm seeing volume. I'm thinking area of the base times the height. Okay. In cubic inches. So I want to find the area of this triangle. I'm going to find the area of this triangle, and then I'll just multiply that by this height going across. So we need to know the area of a triangle. Area of a triangle is 1/2 base, which in this case is 6, times height, which is 4, and then times the height going all the way across, or the length going all the way across, so times 10. So this here is our big B for area of the base, and this here is the height. Okay, so I could do this in my head here. So that's going to be 12 times 10, and that volume will be 120 cubic inches. Since we're multiplying by 3 things here, inches, 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 that's why it's going to be inches cubed, and they say in cubic inches. Okay, so just moving along, I think I'm going to skip 2. Looking at 3, so this says the volume of a rectangular prism in cubic inches is 144. The height of the prism is 8, which measurements could be the dimensions of the base. So I went ahead, I drew the base here. I'm going to try my best to draw this. Okay, let's make that black. Okay, so drawing this prism here, this rectangular prism, I have the base is a rectangle. So we're trying to look for the dimensions of this rectangle. That's what we want to try to find. We want to find the dimensions of this base. Okay, so they tell us the volume. We already know the volume is 144. We know the height is 8. We're kind of looking for this length and this width. So volume is area of the base times the height. We know what the volume is. It's 144, and that's going to equal base times 8. The area of this base is a rectangle, so that's length times width times 8. All right, so we need to figure out what the length and the width need to multiply to be. So to kind of isolate this area of the base, to isolate that, I'm going to divide by 8. Okay, so if we do 144 divided by 8, we're going to get 18. So 18 needs to equal the length and the width. The area of the base needs to equal 18. So at this point, we'll just kind of go through and multiply. I already could tell you 9 by 9 is 81. That's not going to work. 12 by 8 is going to be 96. That's not going to work. So let's kind of check out these other ones. 3.3 times 5.5. Now that's 18.5. So then 2.5 times 7.2. And there we go. That gives us 18. So if we went ahead and multiplied this, that gives us 18. So it's going to be choice 2. Okay, 4. A right prism has a square base. Okay, let's try to draw that out. Right prism has a square base with an area of 12. The volume is 84. Determine and state the height of the prism in meters. Okay, so just drawing this out here to get a visual. So we have some different information than the last one, but it's really going to be generally the same idea. They tell us what this area is. They don't tell us the dimensions of the length, the dimensions of the width, or the sides, since it is a square. That's fine, though. They do tell us the area is 12. And they tell us the volume is 84. Determine and state the height of the prism. So any volume is going to be area of the base times the height. They give us the volume is 84. They give us the area of the square base is 12. So now we're just solving for the height. Okay, let's divide both sides by 12, divide both sides by 12. And 84 divided by 12 is 7. So the height has to be 7 meters. All right, great. So those are like your more basic type of volume questions. And I guess at this point I should tell you that you don't need to memorize these. I want to show you the reference sheet, so let me just do that. Okay, so here you go. Your area formulas are all here. 1/2 base times height, pi r squared. And there you go. General prisms, just as we're talking about. Volume equals capital B times H. You just need to know capital B stands for area of the base. Here's cylinder pi r squared, but pi r squared, what is pi r squared? Pi r squared is the area of a circle. A cylinder has a circular base. And then we'll be dealing with sphere, cone, pyramid, but you do not need to memorize any of these because they're there for you. You know, if you were to take regions, it would be there. Okay, so like I said, those are the more basic ones. Now let's take a look at prisms that are not necessarily right prisms. So I have kind of these stacks here, the volumes of these figures here. And we want to know, are the volumes the same? Are they different? How do we know? Okay, so let's just take a quick look. All of their area, or all of their bases have the same dimensions, A and B, A and B, A and B. So their area of their bases are all the same. And actually their heights are all the same too. So if I look here, you know, starting from here and it goes about up to there, that's the same height as the other one. Starting from here and going up to here, that's the same height. So their heights are all the same as well. Their heights are the same. If you have to take the altitude height though. So I need to be specific about that. It's not the slant height, so it's not this height, it's an altitude height going that way. So all of their heights are the same. If the area of their bases are the same, and if their heights are the same, then the figures are going to have the same volume. Doesn't matter what type of figure it is. We could have a a triangular prism and a rectangular prism, and if the area of the triangle and the area of the rectangle are the same and their heights are the same, their volumes are going to be the same. And that's what we actually call Cavaliere's principle. So it's kind of this long-winded thing here, but basically Cavaliere's principle states that if two solids have the same exact area of their base and their heights are the same, then their volumes are going to be the same. If we take a look here, we have two different types of solids. One is a right square pyramid, and the other is a trapezoidal oblique. Oblique means it's kind of like slanted. It's not straight up and down. So we have an oblique trapezoidal pyramid. So this is my trapezoidal pyramid, and we call it oblique because it's basically slanted. So that, and we have a square pyramid. So Cavaliere's principle is going to hold true because basically, as long as their area of their bases are the same, so if these capital B's here are the same and their heights are going to be the same, then their volumes are going to be the same. So if these wound up being the same, then they would have equal volumes. Okay, so this says both are equal height, and they have equal area cross sections here. So you can take a cross section, I guess, in the middle and in the middle, but normally we kind of look at it from the bottom here. Yeah, Cavaliere's principle will hold true. Okay. So let's take a look at another type of question. This was a regions one. So we have Sue believes that the two cylinders shown in the diagram below have equal volumes. Is Sue correct? Explain why. So let's go ahead and take care of that. So we'll do cylinder 1, cylinder 2. So for cylinder 1, the volume is going to be area of the base times the height. Since this is a cylinder, specifically, it's a circle, so pi r squared h. The radius is 5, so 5 squared, and the height is 11.5. Okay, so volume equals, let's do 25 times 11.5, 287.5. Okay, so 287.5. So 287.5 pi, that's the volume of that one, and that's going to be in meters cubed. And the cylinder 2, again, volume equals area of the base times the height. So volume is going to be pi r squared h. I see that the radius here would be 5, just like the other one. And I see the height is going to be 11.5. We always take the height from like the altitude height making the right angle, not the slant height. So 11.5. Okay, and volume is going to be 287.5 pi meters cubed. So it asks to explain if SU is correct. So we could see here in a couple of different ways. We actually calculated the volume, so we know that SU is correct, but I could say SU is correct since the area of the base and the area of the heights, area of the bases and the area of the heights are both the same. Both volumes are 287.5 pi. 287.5 pi meters cubed. So yeah, that's would be a perfect explanation. We showed our work, and there you go. Moving along a bit. Okay. So we have another one here. We have shows two figures. Figure A is a right triangular prism, so nice right angle here. The other one's oblique, meaning that it's like a little bit slanted. We need to basically use Cavalier's principle to explain why the volumes of these two triangular prisms are equal. So volume equals area of the base times the height. So for figure A, volume equals, it's a triangle, so 1/2 base times height times like long height, I guess we could think about it like that. So 1/2 base is 8, height is 5, and the height going up and down is going to be 14. So that's going to be, let's see, 20 times 14, 280. So volume is 280. And figure B, volume again is 1/2 base times height, then times the height going up. 1/2 base is time is 5, that height is 8, and the long way across is 14. We wind up getting the same exact volume. So the volumes are the same, they're both 280. Now we have to use Cavalier's principle. So we have to talk about what Cavalier's principle is. And basically Cavalier's principle is just as long as the bases are the same and the heights are the same, then the volumes will be the same. So we could say something along the lines of, since the bases of both prisms are equal and the heights are equal, then the volumes will be equal. Both prisms have a volume of 280 units cubed. Okay? So that's really it. Now, the big takeaway here is when it says use Cavalier's principle, we have to talk about the, since the bases of, I need to kind of end it, since the area of the bases of both prisms are equal. That's actually really, really important. And I want to highlight that and stress that because that is important. It's the fact that the area is equal, not just the bases, because like that's a little vague. You have to state that the area of the bases are equal. I want to go back here and just see if I said that. I wrote it in here, yeah. So I wrote it there. I just needed to amend it over there. Okay. So I think we're going to stop there. There were a couple of other questions, but we don't need to do all of them. The next one after this, you'll do kind of like an independent video worksheet on your own. So that's it. Till next time. Bye, guys.